is something that you're going to have to write, as you will see, because that's in bold. So I don't know why I wrote them separately, but I did. But basically, you have to prove to me that you know the linear steps of the scientific method and how they correlate to the steps used in diagnosis. So in the third bullet point, I give you observation, questions, hypothesis, experiment, second observation, questions, second hypothesis, and then treatments. So, basically, I gave you the example, and it's the one that I would probably use, if you've got a better one, of the flu. You come into the doctor right now, and you say, I have a fever and an achy pain in my muscles. We're going to tell you you have the flu. So go home, take some aspirin, get some rest, drink plenty of fluids, right? But this is the big but that you have to use in this essay. You're gonna say in a week or so you're not better. So you come back to me, if I'm your doctor, and you go, I still hurt, I have fatigue, I still running a fever. Hopefully if I'm a good doctor, I'm gonna go, ooh, you don't have the flu. The flu should have been gone by now, right? So now I'm gonna have to do what? I'm gonna question you more, I'm gonna observe you a little bit more. I'm probably gonna ask you a bunch more questions, like where have you been? What have you been doing? What have you introduced new? New foods, new whatever. Have you been out of the country? Because now I got to start thinking, do you have a parasite? Do you have, well, what's wrong with you? So now I'm going to do what? A blood test, urine analysis. If it's gone to your lungs, I may take an x-ray, right? So now I need a lot more information because I was wrong the first time. So that's what I mean. So now I'm going to have to, Jerry, go in and do more testing, come up with a new hypothesis. I'm now probably going to send you home with another medication and see what happens. And hopefully you won't come back and that I was right the second time. Okay. All right, so can everybody feel like they can do that? All right, I mean, that's just make sure you use observation or questions, a hypothesis, a treatment, and usually it's, we're probably not going to experiment on that first one because we're going to assume you have the flu, right? But we are going to give you, tell you to take aspirin, all right? Okay, then bullet point number 2, it says, know that most scientific research is circular in nature. Well, I gave you the example of what the public perceived as misinformation in the COVID pandemic. Because all we were doing is we're telling the public new information that we had on new data, and everybody thought, well, they don't know what they're doing. No, we were just collecting data on something we knew nothing about, and we kept getting better data as time went along. And so it was very circular. We couldn't make up our mind because we had conflicting stories from different countries, and so we were trying to figure that all out, and we looked like fools, and we didn't communicate it very well, but it didn't surprise me that that's the way it went down, okay? So just know, I'm gonna ask you that most, pharmaceutical research is circular in nature. We don't follow that linear form like we do in diagnosis. Does that make sense? Okay. So this is going to cover a couple things, but it's okay. So be able to distinguish between the experimental group and a control group. Just look at the words. An experimental group, we're going to do an experiment on. We're going to do a treatment or a drug on them. The control group has nothing done to it, but if we're giving a drug, we're going to give the control group what? A placebo. Know the importance of randomization, Enrique. So the importance of randomization is basically so I don't have bias. That's what I'm getting at. So in other words, if I am testing how many of you like hazelnut coffee, and I come in here drinking hazelnut coffee every day, and some of you are going, like Haley over here, like no, and some other people are going, I love the smell of that, So if I want to prove that hazelnut coffee is great, and I select all of you that love hazelnut coffee in my group, it's going to come out that everybody loves hazelnut coffee. Is that biased? Yeah, I did not randomize my sample, right? I selected it. That's called selection bias. So you can't do that. So that's why we randomize things, so that we don't create bias through our selection. Okay. So next one says be able to recognize bias in scientific research. So I have written this test, so I'm telling you, I'm giving you an example, and you're going to have to pick out the bias. So I'm going to say which of the following best represents bias in a scientific experiment, and then I'm going to give you 5 selections, and you got to figure out which one shows bias. Okay, that's what I mean by recognize there. So who can tell me what a confounding variable is? Anybody tell me what that is? Matt? You should know a confounding variable.
Is that like the one where it's like the thing that you're looking for to see if it happens?
No. Confounding variable.
I want to say something else that is like affecting.
Something else that might affect the results of the study.
Yeah.
So for example, these usually happen in observational studies, which are not very good because they're correlations, right? So I gave you the example of, hey, married people live longer than single people. Well, they might live at a zip code where they don't have access to good food. So does that mean that they, that could be a confounding variable where people are living in a shorter amount of time and they just happen to be single in that area. So that's a confounding variable, right? Or it could be because the wife is more responsible than the husband and says, no, you can't drive a motorcycle. And the single people do whatever they want and they do dangerous things. So is it because of the bonding, or is it because of the responsibility? So those are confounding variables. We can't prove that it's the bond between the couple that actually makes them live longer, right? It could just be that, hey, since I live with another person, I don't smoke because they don't like smoking, so therefore I've modified my behavior. Does that mean the bond between us did that? No, it's just that I don't do that, right? So those are confounding variables. And again, you're just going to have to be able to recognize those. This next one, just write down. I'm going to try to trick you. I am. It says, know what a placebo is and how it's used. Is a placebo necessarily a sugar pill?
No.
Okay, remember I told you that.
It just doesn't have the active.
It does not have the active ingredient. It may have other ingredients that have no physiological effect. Okay, but it does not have to be sugar, right? So, because we need to make that pill look, taste, feel, everything like our original drug. So I can't do that if it's just sugar. The second part of that is understand the psychosomatic effect or the placebo effect. So why is it that I am giving a placebo?
Because sometimes telling somebody that they're taking something that will make them better makes them better.
Right, or just the process of taking something, right? So if I'm trying to figure out if my drug that I am testing in my experimental group actually works, I'm giving a placebo because just the fact that I have a person taking a drug and they know they're in a clinical trial and they're not sure whether they're getting the drug or not, they might believe they're getting better, and they might actually do better than the actual drug, which again happens about 80% of the time. So in other words, I have to test to make sure that just belief of getting better is not better than the actual drug I'm testing. Does that make sense? Okay. So be able to recognize a randomized double-blind placebo-controlled study and why it is the gold standard. So we've talked about why we randomize to eliminate bias. We know what a placebo means so that we're not giving a psychosomatic effect. Why is double-blind the gold standard? And how do I prevent bias there? Right, so neither the experimenter nor the subjects is how I'll probably word that, or the subjects of the experiment, they don't know. And the reason that's the gold standard is because if it's only a single blind, I, as a scientist, if I developed the drug, I might display bias, right? And I gave that example in class, I think, where I developed an MS drug and I said one person was getting it and the other one, I don't know if you're getting it or not, right? And I treated them differently. So that could introduce bias. So if I'm blinded though, whether I'm giving that drug or not, I have no way of a tell, right? Everybody understand that?
Mm-hmm.
Everybody cool? All right. You guys behind me yell at me because I got my back to you. Know why controlled blinded studies are so hard to administer in nutritional studies? Because I can't blind you to the food you're eating, nor can I give you a placebo for that food, right? I can't give you a fake banana and have you believe that you're eating a banana. Be able to recognize why pharmaceutical and hospital stays can be so expensive. Overhead, R&D, right? So we explained that. Why did it cost me $63 for my Tylenol in the hospital when I could have bought a bottle for $1.20 for 100 of them? Well, because I'm paying for you guys, and I'm paying for the bed I'm sleeping in, and the maintenance, and the lights, and the water, and all that stuff. So it's overhead. Know that sample size influences the reliability of scientific study. Absolutely. The larger the study, the more significant. You guys answered that in the case study, right? You rather take a drug, test it on 5,000 people rather than 500, because chances of knowing that it's okay is much greater. Recognize why scientists use animal models. It's because they're cheaper. We can control everything about them. I can control exactly how much they eat. I can control their wake and sleep cycle. I can control how much they exercise. Basically, I can control everything about it. I can't do that with humans, right? So, again, animal models, as you will I'm going to go over again. They're at the bottom of the pyramid. They're not a good comparison. So they're pretty poor in nutritional studies. Other thing there is to know that there is no definition of good for you. So when nutritional studies come out and say this is a good food or this is a bad food or you should eat this instead of that, well, we don't really know what's good for you means, right? Is that good? Is it good for your cardiovascular system? Is it good for your urinary system? Is it good for your endocrine system? What does that mean? We can't tell you that, because it might be good for some of your systems and bad for others. So this is why we try to stay away from good and bad. Be able to recognize if surveys are reliable or not. They are not. And it depends upon how they were randomized and the questions and the type of survey that is set up. And again, I won't go into those different surveys. I just want you to realize if it's a study that involves a survey, you should be very skeptical of it. Be able to recognize why it is important to look for and cite peer-reviewed journals. Well, again, peer-reviewed journals are going to go out to experts in that field. So, like if they're doing experiments on nutrition, even though I teach nutrition, they're not going to send it to me because I am not a certified nutritionist. I am not a doctor. I'm just a little Negro master's degree in biology. So they could care less what I think about nutrition, okay? So just know that they're going to go out to experts in the field. Then be able to recognize why it is important to share scientific findings. Well, because when we find out that beta carotene kills you if you're a smoker, wouldn't you like to know that if you were a smoker? So we want to pass on information that is going to make you healthier, right? Be able to distinguish between experimental and observational studies. So again, experimental studies are going to run an experiment. They're going to use a control group and an experimental group. Observational studies are just using data. They're not experimenting on anyone, okay? So they could have a control group, but they're not going to have an experimental group, really. And so what goes along with that is further down here. So I'll wait to mention that here in a second. So I'd kind of star that one. We're going to come back to that one. Be able to recognize the matched pairs experiment. That's going to be twins, same gender, same age, same race. So, for example, if we're dealing with sickle cell anemia, well, that's primarily in the African American population, so it's not going to do me any good to test other populations, so I'm going to test the African American population, okay? Or the example that I gave you was of the brothers, the Kelly brothers. One was an astronaut, went to space, the other one stayed at home. They're identical twins, and then we compared the differences of what happened to the one in space versus the one that stayed here. Actually, I think they were both astronauts, but one just no longer in space. Let's see here. Repeated measure study. That's when you experiment on yourself. I gave you two examples. I gave you an example of the guy who infected himself with H. pylori and then cured himself with antibiotics. So he's experimenting on himself. I experiment on myself all the time. I told you I change diets and I looked at my microbiome, right? I completely changed my microbiome due to the experimentation I was running on myself. I'm sure that a lot of you do that in some way or in another. Know what types of studies show correlations and what type of studies show causation. Well, that's where I told you to start your experimental and observational. Observational or epidemiological can only show you correlations. They cannot show you causation. I have to have a comparison, right, to tell you that this caused that, because I've eliminated it to basically one variable. So experimental studies show causation.
And observational shows correlation.
Correlation. All right, so these next two we're just going to cover together. So be able to distinguish between a systemic review and meta-analysis, and then know the hierarchy of scientific evidence and which are best and which are worst. Now, I will ask two separate questions on this. This is not one question, but these two things kind of go together. So let me cover the pyramid. At the bottom of the pyramid, if you'll remember, the worst types of studies, the studies I really don't want you to look at, are going to be expert opinion and animal studies, especially when it comes to nutritional studies. The next worst is going to be observational studies, right? Based on surveys and data. I don't really want you to use those. And then the next level is going to be randomized control studies or experimental studies. And then I'm going to get up to systemic reviews, and then finally meta-analysis. So meta-analysis is at the very top. So now let's distinguish between what is a meta-analysis versus a systemic review. Why is meta-analysis at the very top and systemic review is just below that?
Because you're comparing multiple different studies that different experiments have been done.
You just described a systemic review. So what's the difference? Are systemic reviews good? No, they are, because they're at the top, right? So again, systemic reviews are, let's just say that let's use the Mediterranean diet. I want to compare the Mediterranean diet to other diets. I know, is the Mediterranean diet better? So I'm going to go out and search the literature for everything that compared the Mediterranean diet to other diets. And I'm going to find 1,000 papers. And of those 1,000, I'm going to find 100 that are going to set up their experiments similar to what I'm going to do mine. And the question that I'm asking. So I have a fairly good idea that the Mediterranean diet is already better because most of those papers found that out, or it was close, right? So now in a meta-analysis, I'm going to go to those 100 that I got in my systemic review, but now I'm going to run new statistics. I'm going to combine the sample size. So my sample size is going to go way up. I'm going to manipulate I'm going to take data from all of them, and I'm going to run new statistics. And if I find that the Mediterranean diet is better than those other diets at a 95.5% statistical significance, then what? I'm pretty confident that the Mediterranean diet is better, right? So that's the key difference. In a meta-analysis, I am analyzing new data. That's how you can kind of remember it. A meta-analysis, I'm analyzing new data. I'm running new statistics, and I'm increasing my sample size. Does that make sense? Okay. Phase clinical trials. What's phase 1 do?
The dose.
Dose and
Side effects.
dose and probably I'll write safety. think I wrote safety, right? So dosage and safety is phase 1. Phase 2, what am I doing?
Or no, looking for the max safe amount.
No, we just said, that's gonna be phase 1. Phase 1 is the dosage and safety.
Phase 2 is like if it's something that could help smokers, you only do it on smokers, right?
Well, that's the placebo. We do a placebo in phase 2.
You do have a placebo in phase 2, so you're gonna have, you have both a control group and an experimental group. I am testing if the drug works, right? So I am gonna have both an experimental and a control group. So I'm just testing to make sure that the drug now actually works. So in the first phase, if I'm testing a cancer drug, I may not have cancer patients. Now I'm gonna have a group of cancer patients, the whole group, but one of them is gonna get the drug and one of them is gonna get placebo. So I'm actually seeing if that cancer drug works on cancer people, right?
So safety doesn't work.
Well, I've already determined that it's safe to give to people. I'm now testing to see if the drug actually works on cancer.
Yes.
So I've got to set up a control group and an experimental group, because that's the only way I'm going to know if that drug is going to work on people that have cancer, right? So let's just say that the drug now works, and I think that it's going to make those cancer patients better. Now I got to ramp up in the third phase, and this is the key. In phase 3, now I have to ramp up the sample size. Now I got to see if that works on cancer patients that also have diabetes, that also have heart disease, that are also African American, that are also Hispanic, that are also Asian, that are also females and males, and right? Now I've got to get as much diversity in that third trial to make sure that even if I give this cancer drug to people who have diabetes and cancer, that it's not going to cause harm.
And there's a placebo in this one too, right?
There's absolutely a placebo in that one too. Yes. Does that make sense to everybody? Okay, so phase 1, dosage and safety. Phase 2, seeing if the drug actually works with a control group. Phase 3, we're ramping up sample size and diversity with placebo. Michael, you okay on that, dude?
Mm-hmm.
All right.
That's what, yeah.
All right.
That's exactly.
Everybody got it. Okay. So know that pharmaceutical trials can be stopped and why. So again, I give the example of beta carotene and smoking, right?
It's not safe.
We found that we found early that beta carotene might prevent cancer. So we divided groups up, and what we found, we had smokers in both our control and our experimental group. But in our experimental group, they started dying at a high rate and developing cancer at high rates. And we're like, holy crap, because they weren't doing that in our control group. And so we knew that giving beta carotene to smokers was giving them cancer. So we had to say, stop. It's not good. It is. It's going to in the supplements in higher amounts.
Okay.
Yeah. So again, difference between scientific theory and hypothesis. Just remember, how we use the term theory in English is not how we use it in science. A scientific theory has been proven time and time again in multiple disciplines at a 95.5% statistical significance. It's about as close to a fact as you can get. A hypothesis is a prediction or an educated guess. And many people in the English language will say, I have a theory about that, and what they really mean is they have a hypothesis about that. So who can tell me the 3 characteristics of a good hypothesis?
Is it testable?
Testable,
Bias?
unbiased, not biased, unbiased, and
Can be repeated.
can be repeated. Repeatable. So again, those terms really kind of came out of, you got to remember that science was part of religion. And so, can I test? Do I have something physical to test? I have to be able to run an experiment on it. And back in the day in philosophy, there were many people that said, we're testing this. Well, because they believed in a God, so they were kind of biased, right? And then other philosophers couldn't repeat that. So that's really where it came out of, are those 3 things. So recognize why there is replication crisis. Well, because currently we have a lot of drugs on the market that don't do what they say they're going to do, because we have not repeated those experiments. And the reason that we have not repeated them is because of funding, right? Nobody wants to pay to redo an experiment that's already been done. So this is why we have drugs that are actually on the market that are kind of dangerous, because we haven't tested them more than that once. And the way to fix that is to improve funding, right? And that's really all you need to know about that. The last 2, if you go back and look at your notes, you'll see the CRAP test and the SIFT method and the red flags and the junk science warnings. Don't go memorize all that stuff. I talked about that in the last class. What I'm going to do again is I'm going to give you examples. So I'll just say which statement below best represents, or raises red flags for you, right? So if I tell you that there's a prince from India that wants to give you money if you'll just send them $1,000 in gift cards, I hope that you don't pick that. Sorry. Because I'm going to kill you. Because that is not a good thing to do, okay? And trust me, I had a very good friend's mother who was on her deathbed, and she's now passed away, who got scammed while she was very sick and ended up giving away a lot of money that he would have inherited in exactly that scheme. She went out and bought a bunch of gift cards somewhere because somebody told her to do it. She was elderly and was scared that she was going to lose her inheritance, and ended up giving her inheritance away. So that's why I say that. All right, so the very last question is not from the research and scientific method stuff. It goes back to your reflection paper, which I have graded all of them, except there's a couple of you that I could not find anything where you turned in a paper. So some of you I need to talk to. So, for those of you that I made comments on your paper, even though you couldn't read them, so if you're having trouble reading my handwriting, if I handed that back to you in person, let me know. Other than that, I've made a comment in Canvas on your paper, so make sure you click on your grade and you look at the comment that I made on your paper. Here's the question I'm going to ask. So I'm going to go over exactly what I want. So please write down what I want. And then write it out before Friday. explain how food choices put most people at a moderate level of health on the health line, and be able to explain why it is so hard to go up and so easy to go down on the health line. So I probably need to add to that a little bit. I'm probably gonna say, explain how food choices and zip code / circumstances or maybe access. Okay, so let me explain what I'm saying here. The key thing is that the majority of Americans that are a moderate level of health. So, to make this easy for me, because this is on a Friday and I gotta have my grades due. Look, can you tell me the 3 top reasons for food choice are taste, time, and convenience? Can I get myself in trouble with those 3 things, those 3 choices as far as food? How? How can taste get me in trouble?
Cause-
You're eating what sounds good rather than what's actually gonna benefit you.
Right, like
Yeah.
cookies and cakes and
Processed food.
processed food, right? Because I had heartburn last night because I watched the Chiefs lose again and ate chicken. Okay,
That was rough.
and so how can time get me into trouble?
Busy schedule, fast food.
Right, so I'm a busy schedule. I don't have time to go shop. I don't have time to cook things that are healthy, right? So, and that goes along with convenience, just like Haley said, because now where am I going to stop? McDonald's,
Taco Bell.
Taco Bell, Taco Hell, or whatever they call it, right? So now
really
I'm
Taco Bell.
really poor. I'm going to make poor food choices because of
Ooh,
convenience,
on my way to work.
right? So is that going to get me in trouble?
Oh yeah.
Absolutely. So if I take all 3 of those, I might get diabetes, I might get heart disease, I might have high blood pressure because I'm eating a bunch of salt, right? So now you see why the top, cancer, heart disease, all of those things are at the top. It's us making bad food choices. Does access have any influence?
A lot.
So, right? So basically, zip code. Do you have access to parks? Do you have access to education? Do you have access to healthcare? Do you have access to grocery stores? Right? Do you have access to transportation? Because if I don't have those things, can I stay healthy? Do I have access, right? If I don't have access to a gym or a place that I can exercise, and my doctor tells me to exercise, how am I supposed to do that, right? So if they tell me I need to, go somewhere and I don't have a car, how the hell am I gonna do that? So will that affect my health? Absolutely. All right, so now everybody understands, correct? How either your food choice or your zip code can affect your health. Are we clear on that? Everybody can write on that. Good. Make sure you write on that soon. I just gave you some good examples.
Just right now.
Now, let's tackle the second part of that. Why is it so hard to be at the top? Why is it so hard to be at the superior level of health?
Because you can't be in perfect health all the time.
And what is health?
All
Health
the
is
aspects. Physical.
What-
every
Physical, mental, emotional, spiritual,
social.
and social. So, can I be at all 5 at the same time?
No.
Well, I'm telling you, I can't do that. I'm not there right now. Okay? So I am not at a top level. I'm definitely not in a superior level of health. Right? And I even know how to get there. I just won't. So, how is it that I could, if I develop diabetes, why is it gonna be, if I'm at a moderate level of health, I'm a pre-diabetic, why is it gonna be so easy for me to slip into diabetes and heart disease from my moderate level? Right, because now I have to develop new habits. I actually have to not eat everything that I like. Gonna have to do exercise. I'm gonna have to follow somebody's directions, which I don't like to do because I have a big ego and I'm not gonna do what people tell me to do, right? So we're stubborn. And so most patients are non-compliant because we don't like to be told what to do. We want to eat what we want to eat when we want to eat it, right? We don't like to exercise because it, again, takes time. So all of those things that we just mentioned, time, convenience, and taste, are going to get in the way of us doing what? Improving. We're going to keep on doing what we've been doing, and guess what? We're going to get worse. Does that make sense? All right. That's what I want a paragraph on. Can everybody, you got enough down to figure that out? One paragraph. One paragraph.
That's a lot to put in one paragraph.
You can do it. Trust me, you can do it. It takes two, all right. But be short, sweet, to the point. Remember, I gotta get this graded.
Thank you for
I
sharing.
got
this.
160 of you graded.